In this video, we're going to work out the volume of this solid. The surface, the blue surface, is given by this equation. So this is really a paraboloid that concaves downwards. So that's a paraboloid, and this equation here describes the cone. So you can imagine this as being like this. So this is our cone, and this is our paraboloid. Our job is to work out the volume here. But in order to work out the volume, we need to work out the region in which we're integrating over, this region here. So to come up with this region, we would need to find the intersection of the cone, which is this thing here, and the surface, the paraboloid. So it intersects along here. It intersects along here. It intersects along here. So you can project it down onto the XY plane, so it will look like this. You can project it onto the XY plane, so it will form some sort of circle at the bottom here, flat on the XY plane. Okay, so around the back, project it downwards, and then it will hit here. Project it downwards, it will hit somewhere around here, and so on. So you can see that it forms some sort of circle. Well, that's going to be our region in which we're integrating over. So let's begin. So to work out the volume of this solid, we will need to work out the volume underneath the paraboloid. So we've got our region here, which is R, and then we've got our paraboloid, this paraboloid here. But if you integrate the surface over our interested region, it will give you this solid. It will give you this solid, and then integrate it over the same region. But then here you can't really see it on here, but there's some sort of cone here. There is some sort of cone here. So this is our surface, which describes our cone, and then so that's our surface there. This bit here is our surface. That's our surface. But then when you integrate it over this region, which is our circle here, which is the same region as this thing here. So if you get this whole volume, take away this volume, then it will give you our intended volume. Okay, so the volume is given by this, take away this. So the next step is to work out the region in which we're integrating over. So to find that region, well, if you look at the equation for the paraboloid, this paraboloid here is given by this. If you look at the equation for the cone, it's given by this. So if you want to know the intersection of the two surfaces, set one surface to equal to the other surface. So that will then take us to here. And then we're going to use polar coordinates to do this. So factorize out, well, merge these two together. That will then give us this. So now using polar coordinates, this thing here equals R, and this thing here equals R squared. So that will then take us to here. Times everything by 4. That will then give us this, and then factorize it. That will then give us this. So what that means is the intersection of the two surfaces. What that means is the intersection of the two surfaces, that's this bit here, is really, in polar form, it is a radius of 2. A radius of -6 is meaningless to us. So let's just ignore this and just concentrate on a radius of 2. So this thing here, the intersection of the two surfaces, will have a radius of 2. So what that means is this is a circle of radius 2. So the equation of our region is really R equals 2. Radius always being equal to 2. That's the region in polar form. So now hang on. So now back to this. We ultimately want to work this thing out, but we need to convert this into polar form. So that will then take us to here. And then if you look at our surface converted into polar form is given by this. We did it earlier. And then we're integrating over R from R equals 0. Remember, this is our region here. And then we're well, hang on, if you look at xy, you're really integrating from r equals 0 to r equals 2, r equals 0 to r equals 2, r equals 0 to r equals 2, r equals 0 to r equals 2. So you're integrating from 0 to 2. And then angle wise, you're doing it from 0 to 2 pi. So this solid here is given by this. This solid here is given by, well, remember, this thing here is really r. And if you convert this into polar form, it will then give you this. And then you're doing it from a radius of 0 to a radius of 2. And you're scanning the angle from an angle of 0 to an angle of 2 pi. So this volume here is given by this. So if you get this, take away this, it will then give you RV. So so now that will then take us to here. So we are currently here. And then tidy this up. So if you multiply this out, it will then give you this. Merge these two together, that will then give you this. Now integrate this with respect to r. That will then give you this. Integrate this with respect to r. That will then give you this. And then you would put 2 into here. That will then give you 6. Put 2 into here. That will then give you 1. And then if you put 0 in there, it will be 0. So this thing here becomes the number 5. And then this thing will then become 8 over 3. So so we are currently here. And when you integrate the number 5 with respect to theta, it will be 5 theta. From 0 to 2 pi. From 0 to 2 pi. And when you integrate this, it will then give you this. From 0 to 2 pi. From 0 to 2 pi. So overall, the volume is given by this. Okay, so that's our volume there. Okay.